Hi everyone, my name is Ravi Prakash and we are doing number system 2. This is the fourth class of factors. Okay, so today we'll discuss about product of factors, right? Now see, about the concept of product of factors, let me take a number 48. Okay, so 48 is a number now. Let's write down all the factors of 48, right? Not in the prime basis as we have seen in earlier videos. Just simply let's write down the factors, right? First, 48 factors are 1, 2, 3, 4, then 6, then 8, then 12, then 16, then 24, then 48, right? So there are total 10 factors, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So total there are 10 factors for 48, right? 10 factors. Now see, once you write these factors in ascending order, right? Once you write these factors in ascending order for any number, you can see it. This 48 can be written as 1 into 48, right? 1 into 48. Then 2 into 24 is also 48. Then 3 into 16 is also 48, right? 4 into 12 is also a 48 and 6 into 8 is also 48, right? So this is like factors, right? This is property of any number for any number. When you list down all the factors in ascending order for any number, the product of first and last, second and second last, third and third last, like this, whatever are the number of factors, this product will always give me that number, original number, right? So this let me write a question here that in how many ways a number can be written as a product of two factors. In how many ways a number can be written as product of two factors, right? And let's say for now that number is what? That number is 48. Okay, so let me make this number as 48 now. Okay, 48. So 48 can be written as a product of two factors, right? So what we can simply do here is, in this case, when we list down all the 10 factors of 48 here, all the 10 factors of 48, right? So obviously there will be 5 pairs, right? What are the pairs? 1 into 48, that is first and last. 2 into 24, that is second and second last. Then 3 into 16, that is third and third last. Then 4 into 12, that is fourth and fourth last, right? Sorry, 4 into 12, that is fourth and fourth last. And then 6 into 8, that is fifth and fifth last. That is basically fifth and sixth factors, right? So there are 5 ways, right? 5 ways. So if we get this concept here, that means we don't need to always write down all the factors, right? What simply we can do is simply list 48 as a product of its prime basis, right? In prime basis, what is 48? 48 is 16 into 3. What is 16? 2 raised to 4 into 3. So how many factors? 4 plus 1 into 1 plus 1, right? Power plus 1. So 5 into 2. Total there are 10 factors. So if there are 10 factors, that means there will be 5 ways, right? There will be 5 ways. Just half the number of factors, right? Half the number of factors. That's it, right? So very important concept, right? This one. Now, we'll do it for perfect square, for non-perfect square, right? Everything we'll do. But here a small confusion will always be there, right? That when to write the answer as 5 and when to write the answer as 10, right? That is ordered and unordered, right? So earlier also in many videos I've discussed ordered and unordered, right? Let's discuss here also what is ordered and unordered solution. Okay, ordered and unordered. Now see, ordered solution and unordered solution. Okay, so these are the two terms mentioned in question. right? Or may not be mentioned in a question, right? So we have to see when to find order, when to find unordered, right? So ordered solutions we find when when variables when variables in question are mentioned. When variables in question are mentioned, then we find ordered solution. Unordered solution we find when variables in question are not mentioned. Right? For example, if I say find number of solutions of a into b is equal to 48. This is a question, right? In just previous slide we did this question where find a number of solutions for a into b 48, and let me write a and b are positive numbers, positive integers, right? So a and b are positive integers. Now variables in question are not mentioned here, right? Not mentioned. That means same question can be asked in how many ways? In how many ways 48 can be written as product of two positive integers, right? Now in this question variables are not mentioned, right? So we have to find here unordered solution. Here variables are mentioned, so you have to find an ordered solution, right? This is a case of ordered solution. This is a case of unordered solution, right? Logic behind is that when a question mentions its variables, right, that means they are differentiating between the variables a and b, right? So when it is given that a into b is 48, that means I should treat 1 into 48 and 48 into 1 as two different cases, right? But in case of unordered we should not do it, right? But in case of unordered, if I write this, then 1 into 48 and 48 into 1 are this, I should write 1 into 48 and 48 into 1 is only one case, right? Only one case. We should not treat as two case, right? This is meaning of unordered solution. Okay, so in ordered solution a comma b and b comma a are treated as two different solutions. In unordered solution b comma a and a comma b are single solution, right? So in how many ways? So for a into b is 48. If I have to find ordered solution, 1 comma 48, right? What is a comma b here? So 1 comma 48 and 48 comma 1 will be two different solution, right? It is a comma b, 1 comma 48 and 48 comma 1, two different solutions, right? Two different cases. But here in unordered only one case, right? So when a question mentioned in how many ways, that means it is unordered, right? So that means you have to take we don't have to take into account the ordering of variables, right? A comma b and b comma a are same in unordered cases, right? Unordered cases. Okay, so for example, if I write here ordered, in ordered and in unordered, a comma b is treated as two different solutions because a comma b and b comma a, right? In unordered a comma b, right, here I should write a comma b and b comma a, two different solution. Here a comma b or b comma a, it's only one solution in unordered, correct, right? So we got to understand this concept, right? So this will move on, right? This is like for counting when there are two variables, there are three variables, right? The concept is this only, right? Because when you write in ABC, so let's say in ABC, So ABC can be ordered in 6 different ways. 6 different ways, right? We have 6 different solutions here, right? 6 different solutions, ways or solutions, right? What are those ways? A comma B and B comma A, 2 for 2 variable, right? There are 2 ways. ABC, ABC. See how many ways? ABC, ACB, BCA, BAC, CAB, and CBA, right? There are 6 different solutions. 6 different solutions. So in ordered, ABC will be counted as 6 different solutions, right? In unordered, ABC will be counted as only one solution, right? Because its order doesn't matter now. Okay, A comma B comma C or B comma C comma A or C comma A comma B all are single. So in unordered, their order doesn't matter, right? So A, B, C's will be only one solution, right? So this, I hope you know that this A, B, C is 6 different ways, directly written as 3 factorial. So 3 factorial 6, right? If you don't know this, please watch my video of fundamental principle of counting, right? You should watch that video, a very important video where we have discussed how to count variables fastly, use of factorials, use of permutation combination a little bit in that, right? So please watch that video of fundamental principle of counting. We don't know this, right? If you don't know this, okay. Now let's come back to the topic now again. Okay, so we're discussing product of factors, right? Okay, so product of factors we're discussing. Next slide. Okay, so in how many ways following numbers can be written as product of 2 of its factor, right? First question is 20. Very easy, right? We just discussed it that 20 can be written as, if I write down all the factors of 20, 1, 2, 4, 5, 10 and 20, right? So in how many ways it can be written as product of 2 of its factors? 1 into 20 is 20, 2 into 10 is 20, and 4 into 5 is 20, right? There are 3 ways, right? There are simply 3 ways, right? This question, mind it, this question is for this unordered solution, right? Unordered solution, because the question says in how many ways, right? Variables are not mentioned in the question. So in how many ways? So there are 3 ways, right? So I can do it directly now. We don't need to list down all the factors. What we'll simply do, 20 we'll write in terms of prime basis, that is 2 square into 5 raised to 1, right? How many factors? 3 into 2, total 6 factors. So 6 factors, so how many ways? Half the number of factors, right? Half the number of factors. There are 3 ways. Half the number of factors, simply, right? Directly I can do, there are 6 factors, so I can make 3 pairs, right? 1 into 20, 2 into 10, and 4 into 5. Now for 720, it's a bigger number, right? So obviously we'll not list down all the factors. Simply break 720 in terms of prime basis. Okay, 720 in terms of prime basis. So what is it? It should be 72 into 10. Again, do it mentally, right? This is again 8 into 9, and it is how much? 2 into 5. So what are the prime bases? Prime bases are 2, 3, and 5. How many power of 2 here? 2 cube here and 2 1 here, right? 2 raised to 4 total. Now how many power of 3 here? 3 square, that's it. So 3 square and 5 raised to 1. So how many factors here? So 4 plus 1, that is 5, into 2 plus 1 3, into 2 plus 1 2, right? Total 30 factors. 30 factors, right? So if there are 30 factors, so how many ways? It should be 15 ways, right? 15 ways, that is half the number of factors. Okay, so 30 factors are there, so there will be half the number of factors, right? So if I list down all the factors of 720 like this, 1, 2, 3, 4, like this up to 360 and then 720, right? So 1 into 720, 2 into 360, like this, I'll get how many pairs? If there are 30 factors, I'll get 15 pairs. So 15 ways, right? So I can write it now that number of ways of writing a number as product of its two factors is equal to half into number of factors, right? Simply half into number of factors, and it is for non-perfect squares. I will discuss the case of perfect square. It is for non-perfect squares, right? Non-perfect squares. Correct. Obviously, it is what? When number of ways are given, or when number of ways are given, variables are not given, it is what? It is unordered solution, right? So it is, obviously it is unordered. It is for unordered solution. Very important, right? Don't do the silly mistakes of ordered and unordered, right? Variables are not mentioned, unordered. Variables are mentioned, ordered, right? Unordered means a comma b and b comma a will be counted as single solution. Ordered means a comma b and b comma a will be counted as two solution, right? Their order will matter, a comma b or b comma a. That's it, right? It's half into number of factors, right? And now if it is right, if it is ordered, okay, so if I have to find order, right, same as in previous slide, if I'll write number of solutions of a into b is equal to 720, right, is equal to 720, where a, b are positive numbers, right? Positive integers, I should write, right? Positive integers, right? So for sure, in this case, the question is for ordered, right? The question is for ordered because variables are given. Variables given in question. Variables given in question. That means it is ordered solutions are asked. Ordered solutions are asked. Right. So again, very simple, right? Same as the last case, right? Same as the last case. What is in the last case? 7. How many ways for 720, right? So we write down all the factors of 720. So 720 was 2 raised to 4 into 3 square into 5 raised to 1. It has got total 30 factors. So there was 15 ways, right? So there are 15 ways to do it, right? Now for this 15 ways, right? What are the ways? The ways are, what are the ways? Ways are 1 into 720, okay, 2 into 360, like this. Okay. So for each way, now it is a comma b, right? So now their order will matter, right? So if I write the solution as a comma b, so 1 comma 720, okay, so 1 comma 720 and 720 comma 1. In ordered, it will be counted as two different solutions, right? Then 2 comma 360 and 360 comma 2. In ordered, again, two different solutions, right? Therefore, for each case, I'll get two solutions. Okay, for each case, I'll get two solutions, right? So how many ordered? So total, if there are 15 ways, there will be 30 solutions of this question, right? 30 solutions. There are 15 ways, there will be 30 solutions for this question, right? For ordered, for every one way, there will be two ways, right? Because what are the ways? One way is 1 into 720. It is for unordered. For ordered, 1 into 720 as well as 720 into 1, right? Similarly, for unordered, one way is 2 into 360, right? So for ordered, one way is 2 into 360 as well as 360 into 2, because here a value is, right, here a value is, if a into b is 720, that means 2 into 360 is one solution and 360 into 2 is another solution, right? So this will be counted as 2. For every one way, two solution, total there will be 30 solutions, right? Total there will be 30 solutions, right? So you can see it, right? You can see it. What are 30 solutions? That is equal to number of factors, because for finding number of ways, what we did, half the number of factors. And when we again multiply it by 2, this 2 will get cancelled, right? Half the number of factors again into 2. That is equal to number of factors. That is equal to number of factors, right? So we can write here that number of ways of writing as product of its two way factors in case of ordered, right? In case of ordered, right? So let me write here. Move to next slide. Yeah, okay. So number of ways of writing a number as product of two of its factors, right? In ordered solution, that is variables will be given in the question. So what is the answer then? number of factors. Why? Because in earlier case it was half into number of factors, right? Now what we'll do, we'll multiply it twice, for every weight twice, right? This 2 will get cancelled, so it will be equal to number of factors in this case. Okay, so two different formulas here, right? You can treat like a formula. Logical derivation, it is number of ways of writing a number as product of two of its factors is equal to half the number of factors if unordered, and that is equal to number of factors if it is ordered, right? So very important. Okay, so let me give a question on this. Okay, the question will be, find number of solutions of A into B is equal to 500, where A, B are positive integers, right? So in this case, for positive, right, it is positive integers, it is given positive integers, right? So for positive integers, right, that means it is basically this question of what? Factors, because factors are always natural numbers, they are positive integers, right? This question automatically turns to factors, right? So what will be the answer in this case? So answer in this case will be simply be equal to number of factors of 500. That's it. Number of factors of 500. How many factors of 500? So 100, what is 500? 5 into 100, that is 2 square into 5 cube. How many factors? 3 into 4. Total 12 factors. So therefore in this case, total 12 solutions. Right? Mind it, in last case we have in last slide we had discussed the case of non-perfect squares, right? Non-perfect squares, right? Here we are discussing also non-perfect square. Next we'll discuss about perfect squares, right? Let me give you one more question. In how many ways 1800 can be written as product of two of its factors, right? So what is the answer here? So answer here will be what? Since 1800 is a non-perfect square, what is the answer in this case? Half the number of factors. Simply half the number of factors, right? So what is the number of factors of 1800? So break 1800. What is 1800? 18 into 100, right? What is 18? 3 square into 2. What is 100? 2 square into 5 square. So it will be like 2 cube into 3 square into 5 square. How many factors for 1800? How many factors? 4 into 3 into 3. Total 36 factors. So what is the answer for our question? Since the question is for unordered, right? How many ways? So variables are not mentioned. Question is for unordered. Here variables were mentioned. The question was for ordered. For ordered, answer is equal to number of factors. For unordered, what is the answer? Half the number of factors, right? So what is half of 36? So answer will be, therefore half of 36, that is 18. So answer is 18 factors for this question. It's not 18 factors, 18 solutions for this question. 18 solutions. Correct. So difference between number of factors, right, in case of unordered and ordered, right? Now move to for cases of perfect square. What will happen in case of perfect square, right? Now see what will happen in case of perfect square here. In case of perfect square, if I write 36, right? 36 is a perfect square. So 36, in case of 36, if I write down all the factors 1, 2, 3, 4, 6, 9, 12, 18 and 36, right? So how many factors here? 4 plus 1, 5 plus 4, 9. Total 9 factors are here. 9 factors, right? So now this number in perfect square, this number will be odd, right? You see, in all the other previous cases which we have discussed, wherever we had taken non-perfect squares, always we had even number of factors, right? Here we have odd number of factor. Why odd number of factor? Because in a perfect square, it's a square root, right? It's a square root. A square root is 6. That will also be an integer. Only in case of perfect square, its a square root will be an integer, right? That's why an extra factor adds here, and even number of factors plus 1, it becomes odd number of factor, right? So point to be noted here is a perfect square. A perfect square has always odd number of factors. Odd number of factors, right? All other positive integers, all other positive integers other than perfect square have even number of factors, right? Even number of factors. Here we have odd number of factors, right? So very important point. Okay, so here we have one factor extra, right? So if I ask you in how many ways, okay, in how many ways 36 can be written as product of two of its factors, right? Product of two of its factors, right? So in this case, you'll have one doubt in your mind that, okay, what to do about this 6 smaller term, right? This 6 term, what we need to do, okay? Do I need to do 6 into 6 or not, right? So always there is a term will be used here, that distinct, right? Distinct term will be used here, right? Why? Because if I write down 36 as a product of its, in how many ways I write 36 as product of its factor, right? So 36 will be out what? 1 into 36, 2 into 18, 3 into 12, and 4 into 9, right? If all factors, if I should say, if all factors are distinct, right? Or all factors are distinct, so how many number of ways, right? So if all factors are distinct, okay, Govind, I need to edit here also here. Again, do it from here, right? After I wrote those two statements, na, again I start from here. Okay. Yeah. So let's come back to 36, right? So I can write here number of ways of writing 36 as product of. Now there can be two questions here, right? There can be two questions. Product of question 1, it's two factors, and question 2 can be product of its two distinct factors, right? I hope you understand why this question arises, right? Why? Because 36 can be written like this, right? 1 into 36, 2 into 18, 3 into 12, 4 into 9, and 6 into 6, right? So this 6 into 6 is this, right? Both are same number, 6 and 6, right? So if in question number 1, if the answer is simply, if the question is simply as product of its two factors, the answer will be, there will be total 5 ways, right? Total will be 5 ways. So simply 5 ways in this case, 5 ways, right? But if the question is product of its two distinct factors, so in this case, what is the answer? Two distinct factor means 1, 2, 3, 4, right? So only in this case, answer will be what? Answer will be 4 ways. Okay, so number of ways of writing 36 as product of its two factors is 5 ways, right? Since there are 9 factors, right? So 4 ways for distinct plus 1 way for not distinct, right? Since these two are same. If it's distinct, so only 4 ways, right? So what is 5 here? So I can write 5 as 9 plus 1 by 2. What is 9? 9 is number of factor. What is 4 here? 4 is 9 minus 1 by 2, right? So I can say number of factors plus 1 by 2 in case of not a distinct, and in case of distinct, number of factors minus 1 by 2. Okay, So let me formulate it, right? So I can write, in case of perfect squares, okay, number of ways of writing a number as product of its two factors, right, is number of factors plus 1 by 2, right? And secondly, I can write number of ways of writing, okay, a number as product of its two distinct factors is equal to number of factors minus 1 by 2, right? That's it. Okay, that's it. So I can write a question here. In how many ways 3600 can be written as product of its two factors, right? Product of its two factors. So what is the question? What is the answer here? Simply number of factors plus 1 by 2, because distinct is not used here, right? So how many factors for 3600? So it is like 36 into 100. That is like 2 square into 3 square, and is 2 square into 5 square. So 2 raised to 4 into 3 square into 5 square. How many factors? 5 into 3 into 3. That is 45 factors. So 3600 has 45 factors. So what is our answer? 45 plus 1 by 2. That is 23 ways. So answer is 23 ways, right? Of course it is unordered. Right? Why? Because number of solutions are asked here, but variables are not given. So it is unordered solution. Okay. Now what if the question is ordered solution, right? What if the question is ordered solution? Okay. So in case of ordered solution, right? In case of ordered solution, you see, if I write a into b is equal to 36, okay, small number I'm taking, number of solutions, okay. So a into b is equal to 36. So how many number of solutions? If a and b are positive integers, that means they are factors of 36, right? Positive integers means factors, okay. If positive integer I'm mentioning here for this question, right, that means I'm asking about factors, because factors can't be negative, okay. So a into b is equal to 36, right? So what are the number of solutions here? So see, you see, 1 into 36, I'll write it as in ordered, because the variables are given here. So the question is about ordered. So in ordered, 1 into 36, in ordered, 1 into 36 will be counted as two cases. 280 into 18 will be counted as two cases, right? One is 2 comma 18, one is 18 comma 2. Then 3 into 12, then 4 into 9. Each case will be counted as two cases, right? But 6 into 6 will only be counted as one case, right? 6 into 6 will be only counted as one way, right? Because in ordered also 6 comma 6 and reverse 6 comma 6 both are same, right? That's why total 9 solutions, right? That is equal to what? That is 9 solutions is what? That is equal to number of factors only, right? So that is equal to number of factors only. Yes. So in perfect squares also answer will be same, right? Like if it was not a perfect square, then also what was the answer, right? For ordered solution, what is the answer? Number of ways of writing a number as product of its two factors in ordered solution is number of factors. That is in case of perfect square also, like here, and in case of non-perfect square also, like we discussed earlier, right? So finally I can formulate it, right? Finally I can write for every number, right? Next slide. Yeah, okay. So finally you can note down this, right? Number of ways of writing a number as product of its two factors in case of non-perfect squares is number is equal to number of factors if the question is for ordered pairs, and it is half the number of factors if the question is for unordered pairs, right? In case of non-perfect square. In case of perfect squares, it is number of factors plus 1 by 2 if the question is for not distinct, right? It is not distinct, right? If the question has nothing mentioned like distinct and not distinct, right, then it is number of factors plus 1 by 2, because if nothing is mentioned, then we'll take it as not distinct, then we'll take it as not distinct, right? And if distinct is mentioned, then number of factors minus 1 by 2, both this in case for unordered pairs, and in case of ordered pairs it is simply equal to number of factors, right? Just practice one question on it, you'll feel simple, right? Don't feel complicated, right? This is I've written very nicely all the fundas here, right? Can do it very easily, right? Let's practice one question on this of each time, and then we can uh, uh, this we can say this topic is completed, right? Let's practice a question now.